everyone, today we're going to be working on Unit 7 LT6 notes, probability. So probability is a measure of estimation of how likely it is that something will happen. Probabilities are given a value between 0, meaning 0% or it will not happen, and 1, 100% chance it will happen. The higher the degree of probability, the more likely it will happen. And the notation P with an A after it, P of A, probability of, means the probability of something happening. So when we're calculating probability, the number of successes, or what we want, is going to be over the total possible outcomes. So you can go ahead and, instead of writing all this, number of successes over total possible outcomes, if you want to write, which makes a little bit more sense to me, if you want to write want over total. That should help. Okay, so let's do an example. Probability of flipping a heads. So if you have a coin, and it doesn't matter what coin you have, you could have a penny, nickel, dime, quarter, but if you have one of those, a success would be getting a heads on a toss. So when you think of a coin, how many sides of the coin are actually a heads? Well, there's only one of them that are a heads. The other side is a tails. How many possible outcomes are there if you're tossing a coin? So if I'm going to toss that coin up in the air and it's going to land on one of two sides. It's going to land on either the heads or the tails. So total possible would be 2, either heads or tails. So according to our probability formula, we get a probability of, remember, we want our want over our total. So we want a heads, there's 1 heads, over our total on a coin, there's 2. So our probability would be 1 over 2, or 1/2. Okay, so now we're rolling a dice. So when you think you just have your standard dice in your hand, just one of them, I guess it would be a die. If you're rolling one die, so think of how many numbers are on an actual die. Well, there's 6 numbers on a die. But if you only want to roll the 1, when you're looking at it, there's really only one on the die. Total possible are 6. So there's 6 sides to a die. We want the 1, so it's going to be 1. Our probability is going to be 1 over 6. And if I were to do that math, if I wanted to divide that out, that line between 1 over 6, that really means divide. So I could use that in my calculator. I could say 1 divided by 6. And if I'm going to round that, I'm going to get 0.17. Okay, so if you round it to your hundredths place, this guy right here is my hundredths place. If I were to put that in my calculator, I'm going to do that right now really quick and get the actual. And really what I got was 0.166. Okay, if we are looking at this one tells us what we're going to do. So does that 6 tell that other 6 to stay a 6, or does it move up to a 7? Well, because this guy right here, this guy is bigger than a 5, because it's bigger than a 5, it tells the one right next to it, which is this guy right there, to move up. And that's how I rounded to my 100th spot. Okay, so now we want to roll a 2 or a 3 on a die. Well, when you think of a die, a 2 or a 3, there's 1 2 and there's 1 3. So there's 2 options, a 2 or a 3. Still, there's only 6 numbers on that die. So if I'm going to do the probability, what I want are those 2 numbers over what my possible outcomes are, which are 6. So if I did 2 divided by 6, I put that in my calculator, I'm going to get 0.33. And that's with a rounded number. Okay, so the next one, rolling an even number. Well, my even numbers are 2, 4, and 6. So there's really 3 on a die of 6 possible outcomes. So now I can say 3 over 6. And if I were to calculate that out, that's going to give me 0.5. Okay, probability of rolling a number. This is greater. This is the greater than symbol. A number greater than 2. Well, numbers on a die that are greater than 2 would be a 3, a 4, a 5, and a 6. Okay, so right there I have 4 numbers total that are greater than a 2. There's 6 total possible. So I'm going to have 4 divided by 6, or 4 6. And if I were to divide that out, I'm going to get a 0.67 after it's been rounded. Okay, the last thing, probability of rolling a prime number. Well, my prime numbers on a die are the numbers 2, 3, and 5. Remember, prime numbers are only divided by 1 and themselves. Nothing else can be divisible by them. So 2, 3, and 5 are my prime numbers. So there's 3 prime numbers on a die. Again, there's 6 sides to a die. So I'm going to take 3 over 6, my want over my total. And if I divide that out, I'm going to get 0.5. Okay, let's switch gears here. Here's a deck of cards in a nutshell, and I'll bring up a little picture. Well, before I bring up that picture, let's just kind of look at what we have. In a deck of cards, there's 52 cards in a deck. Per suit, when I'm talking about suit, and this is when I'm going to bring this picture up right here. All right, I think I got her working here. So when we're talking about cards in a deck, in an entire deck, there's 52 cards. So if I were to count all of these, I would get 52 cards if I were to count each one individually. Cards per suit, when they're talking about suits, they're talking about the clubs, the hearts, the spades, and the diamonds. So, like the clubs, they're kind of hard to see because they're so tiny, I had to look really close. The clubs, and I can't write on them, are the top ones. The first row of black ones, those are the clubs. Okay? When you're talking about the hearts, hearts are obvious because they have hearts on them. So that would be a suit of hearts. That entire row, that entire red row that have hearts on them, those are the suit of hearts. Okay, if you're looking at spades, spades are the third row down. So they kind of look like a shovel without a handle on them. And those are the black ones, and that would be that entire row of spades. And your last one would be diamonds, and I think diamonds are easiest. So when you think about these, like the diamonds and the hearts are easiest. I think the clubs and the spades are the ones that are most forgetful, but just try to remember that your spade kind of looks like a shovel without a handle, and then you can figure out the clubs. Okay, so when we're looking at cards per suit, there's 13. So if I were to count all the way across, I'm going to get 13 of each of the clubs, of the hearts, of the spades, and the diamonds. Okay, cards per number. Well, there's 4 cards per number. When you look at the number 2, notice you have a 2 of clubs, a 2 of hearts, a 2 of spades, and a 2 of diamonds. So there's 4 cards per suit. There's 4 number cards per suit. So when you look at those 2s, there's 4 2s. There's also 4 3s, 4 4s, 4 5s, 6, 7, 8, 9, and 10. Okay? Face cards. Face cards are the ones that have faces on it. So those are your jacks, your queens, and your kings. So each suit, meaning each club, heart, spade, and diamond, has a jack, a queen, and a king. When you're looking at red and black, well, the deck is split in half. Half of the deck is black and half of the deck is red. And in the picture, you see they go every other black and then red and then black and then red. And on those ones, there's 26 of each. There's 52 cards in a deck. Half of 52 would be 26. And then when you're thinking of number cards, the number cards are the cards with just numbers on them. So an ace does not have a number, so that's not a number card. A jack, a queen, and a king do not have numbers, so those are not number cards. When we're looking at number cards, we're looking at the 2, the 3, the 4, the 5, the 6, the 7, the 8, the 9, and the 10 of all the suits. So now when we're looking at the probability with cards, the number of successes are what we want. So think, if we want a spade, and remember the spades are like the shovel ones, how many shovel ones are in the entire row? Well, there are 13 total spades in the entire row. there are 52 cards in the entire deck. So if we want the probability of that, my top number, what I want is the spades over my total, which is 52. If I were to divide out 13 divided by 52, I get 0.25. So a quarter, or 0.25 of the deck, is spades. Okay, if I want just an ace, the probability of getting an ace, if you had that sheet of standard deck of cards that I just showed you, an ace, there are 4 total aces in the deck. There's 1 club, there's 1 heart, there's 1 spade, and there's 1 diamond. So that's 4 total. There's still 52 cards in the deck, so my probability, what I want are my aces. There's 4 of those out of 52 total cards. If I were to divide those out, this is going to be a 0.08 once it's been rounded. Okay, a red card. Well, remember that the diamonds were all red and the hearts were all red. So there are 13 diamonds and there are 13 hearts. So altogether there's 26. So 26 total red cards. Again, there's always 52 cards in a deck. So I'm going to say 26 divided by 52. And if I were to divide that out, that is half the deck, so 0.5. Okay, jack of clubs. Okay, so let's think about this. A jack of clubs. So first look for all your jacks. And there are 4 jacks in the deck. And then you have to look at which one has a club on them. So remember, a club is one of the black ones. The spade is the shovel-looking one. So you're looking at the one that does not look like a spade. Okay, so you're finding the clubs. There's only 1 jack of clubs. And there are still 52 cards in the deck. So this one's going to be 1 over 52. If I were to divide that out, I would get, if I were to divide that out, I'm going to get 0.02 if I were to round that number. Okay? And the last thing is a face card. Remember, face cards are the jacks, the queens, and the kings. So if you're looking at your sheet, you have 4 jacks, 4 queens, and 4 kings. So that's 12 cards total. There are still 52 cards in the deck. So it's going to be, my probability is going to be, I want my 12 face cards over my 52 total. And if I were to divide that out, I'm going to get 0.23. Okay, so now we're going to use probability with word problems. You have a bag with 3 red marbles, 2 green marbles, and 5 blue marbles. What is the probability of randomly grabbing a blue marble? Okay, so remember, this is our want over our total. Okay, so first let's figure out our total. Well, if I have 3 red, 2 green, and 5 blue, and I added all those together, that's going to give me 10. Okay, but they want to know how many blue marbles are there. When I look, it says there's 5 blue marbles, so what I want are the 5 over the 10. I want my 5 blue marbles over my total 10 blue marbles. And if I did 5 divided by 10, I'm going to get a 0.5. Okay, number 2, you decided you wanted to read Harry Potter. You go to your bookshelf and randomly pick one of them. There are 7 total. So remember, it's your want over your total. They just told us the total. So I know my total is going to be 7 because it says there are 7 total. What is the probability that you will not choose the first book in the series? Well, when I think of the first book, there's only 1 first book. We don't want that one. So any of the other ones would be an option. So what would be left would be 6. And if I took 6 and I divided that by 7, I'm going to get a 0.86. You need to make a doctor's appointment next week. What is the probability that it is on a weekday? Okay, so let's first figure out how many days are there in the week. If we counted from Sunday to Saturday, there are 7 total days in the week. But if we want a weekday, that would be Monday, Tuesday, Wednesday, Thursday, or Friday. So there are 5 total weekdays. and there are 7 total days in a week. So weekdays, which are typically your school days or most people's working days, Monday through Friday, over the total days in the week, which are 7. And if I were to divide that, I'm going to get a 0.71. All right, your last one here. There's 4 male and 6 female puppies at a breeder. Well, let's figure out how many total puppies there are. If there are 4 male and 6 female, there are 10 total puppies. What is the probability that you will get a female? So I want only the girl puppies. So it says right here there are 6 female. So this is going to be 6 over 10. I want the female over the total, which is 10. And if I were to divide 6 divided by 10, I'm going to get a 0.6. Okay, that's going to conclude your notes for today. I'm going to, or on Schoology, you'll have access to a deck of cards. You will also have access to the notes and the worksheet for Wednesday's assignment. So before you come back to school on Thursday, if you are not here on Wednesday, your job is to complete this notes video and your homework before you come to school on Thursday, because we're going to keep going. Have fun at the game tomorrow if that's where you're at.